All right, so our topic for today is just final exam review part 2. Again, we're focusing on the written portion of the fall final. Please show all work, simplify all radicals, use prime notation for the resulting image in all transformations. All right, so first up, I'm saying we have these two angles, and they are vertical angles. So when we see that language of vertical angles, we know that the relationship is that they have to be congruent. Okay, and then I'm defining each measure as an expression. And then I'm asking you to find both angle measures. Now, I love a good visual, so let me sketch out a pair of vertical angles. I can never draw these perfectly to scale, but that's okay, right? I'm just giving myself a visual anchor. So let's say that I say this one is F, S, M, and then I have over here A, S, and then R. Okay, then the measure I have here would be 1/4 of x plus 128 degrees. And then vertical angle would be 2 times x minus 19 degrees. All right, there's my picture of it. And now as I build my equation, I know that these angles are congruent. Their measures must be equal. So I can say that 1/4 times x plus 128 is equal to 2 times x minus 19. Now I can make the choice to clear the fraction first, or I could distribute, then clear it, right? There's some options here. I'm going to clear it now. So since I see that there's a fraction here, 1/4, I'm going to multiply both sides of my equation by 4. So times 4 times 4. And when we multiply a number by its reciprocal, right, 4 over 1 times 1 over 4, that's going to clear to be just 1. So this part is really just 1. So on the left, I really just have x plus 128 is equal to 8 times x minus 19. So now on the right-hand side, I do have to distribute that. So now I have x plus 128 is equal to 8x minus 152. Okay, so now I have a nice linear equation to solve. Let me consolidate the x's. So subtract x from each side. So now 128 equals 7x minus 152. Okay, then I'll add the 152 to the other side also. So now I have 280 equal to 7x. Right, I want to solve for x, so now I divide each side by 7. And I get that 40 equals x, which symmetric property lets us just flip that right around to x equals 40. So then I just need to take that 40 and plug it back in. And I need to verify that both of these angle measures are the same. So when I plug back into that first one, I'm saying, well, 1/4 times, in parentheses, 40 plus 128, I'm closing my parentheses, gets me a measure of 42. And then 2 times, parentheses, 40 minus 19, right, I should match, and I do match. So both of these measures here and here both end up being 42 degrees. So 42 here and 42 here. All right, next problem here, I'm saying we have parallel pathways, so we can give that beautiful arrow notation that says parallel. And we want to solve for x, and we want to solve for the measure of angle 1. So when I look at the two angles that are marked as expressions, I need to think, well, what kind of angles are they? What kind of angles are these right here? So these are on the same side of the transversal, and they're in the exterior position because they're outside of the two parallels. This would be interior, this is exterior right in here. So same side exterior angles. they are supplementary, right? So their measures add to 180. Now let's say that you forget that language. That's okay. Remember, you can visualize this angle could slide into its corresponding position right here, and then they'd form a linear pair, right? Linear pairs are always supplementary. So now we build our equation. X squared minus 3x plus 6x is equal to 180. Okay, now if I combine those linear terms here, I have x squared plus 3x equal to 180. Okay, from here I need my equation equal to 0 because I see that it's a quadratic equation. Right, there's my x squared. And I want to factor it, so I need to make sure that I have all of my terms on one side and it's all set equal to 0. So I'm going to subtract that 180. So now I have x squared plus 3x minus 180 equal to 0. Okay, so now as I factor this down, right, what I'm visualizing, product and sum, a product of 1 times negative 180, so negative 180, and a sum of 3. Right, so two numbers that multiply to be a negative 180, but add to a positive 3. So when you run through your options, eventually you find that it has to be 15 and negative 12. So when I write these as factors, I have x plus 15 times x minus 12. Okay, you set each factor, let me slide that over, equal to 0, and then when you solve, you get your two possible solutions, the negative 15 and then the positive 12. So x could be negative 15, x could be positive 12. Okay, but now we need to see if one of them works or if both of them work. So let's say that I try that negative 15 first. All right, so I have negative 15 squared minus 3 times negative 15. Just look at that, looks good. Okay, that would mean that this measure here would be 270 degrees, right? Which is just not possible, right? I can't have a measure here that could be in excess of 180. That doesn't make sense. So that one is out. That must be an extraneous solution. I could solve for it, but plugging it back in does not actually work. So now I try the 12. So I have 12 squared minus 3 times 12. So that would give me a measure here of 108. Seems reasonable. And then 6 times 12, we're at 72. So just checking right now to make sure that those are supplementary. They are. That's good. And then the one that I would want right here would be the supplement of 108. So must be a 72 right here. So my solution for x must be that it's 12. It's the only one that works. And then the measure of angle 1 would have to be 72 degrees. All right, we're good to hear. Okay, next one in 3. Identify the transformation as a translation, reflection, or rotation. Describe the specific effect of the transformation of JOB with the following endpoints, right, listed here. And then transform the figure and draw the resulting triangle. Label the image in the pre-image using proper notation. So let's say that you look at that rule and you kind of blank as to which one it is, right? This is a reflection, but let's imagine you just straight up forget. That's okay. Let's apply the rule. So if I look at my pre-image points, let me just transfer those down. I have 0, 6, 2, 1, and 5, 4. Okay, so for my new points, my image points with the prime notation, I see that they are switching position and sign. So here I should have negative 6, 0, right? I can't have a negative 0, still 0. Here I'd have a negative 1, negative 2. Here I'd have a negative 4, negative 5. So I have my points and now I plot them. So negative 6, 0 puts me right here. Right, that's going to be my J prime. Okay, negative 1, negative 2 puts me right here. There's my O prime. and then -4, -5. Right there is my B prime. Okay, and then I can connect my dots and then kind of stare at it and think, which one is it? Is it a translation, a reflection, or a rotation? Okay, so when I look at these, right, clearly not a translation. It's just not moving it left, right, up, down, right? It should have the same orientation if it was. Then I think, is it a reflection? I go, oh, it is. It is a reflection because I can see that I have a mirror line right in here. And if I'm more technical, I can see that if I start at the origin, I'm going down 1, right 1, down 1, right 1. My slope is just -1. So if I draw that in right here, the equation of that mirror line, right, that line of reflection, must be just y equals -x. And if I double check, remember that the mirror line should be the perpendicular bisector of the segment that connects the J's, the O's, and the B's. And that looks great. So here I would say reflection over y equals -x. Okay, next one. So here I'm saying that we have two triangles plotted. So I have triangle PAN and triangle P double prime, A double prime, N double prime, right? All plotted on the coordinate plane. How could we move this triangle to this triangle position using a series of two transformations? Okay, answers can vary. And ultimately, I would say there's probably about 10 reasonable solutions to this. So answers most definitely vary. I always like seeing just creative problem solving in this type of situation, right? So for me, when I stare at it, I might think, well, to get from here to here, I could reflect. So let's say that I build off here and I think, oh, well, let's just reflect across the x-axis. And really, it could have been any horizontal line we could have used to flip it also. That would have been fine. But let's say I use the x-axis as my mirror. So where P is, I'm 3 away from the x-axis. So I need to be 3 away from the x-axis. Let's see. So 1, 2, 3, right here. So right here is where I would have P single prime. And if I fill in those other points, I would have a point here and here, let's say. No. 1, 2, 1, 2, 1, 2, 1, right here. Okay. So if I kind of make a little sketch of it, here's my new triangle where I'm just leaving P single prime right there. So then I'm thinking, well, how do I move it now to this final position? Now I just have to translate it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then down 1, 2, 3, 4. So maybe one path, one option would be to reflect across the x-axis. Could have also said, oh, as an equation, that would be y equals 0. That's fine. And then I could translate it 10 right and 4 down. Right? That would be fine. Okay, if I look for another way to do it, maybe you see it as, well, couldn't I just rotate to this position? Maybe rotate and then translate to this position? Let's try that. So let's rotate around the origin as we tend to do. So if I rotate this 180, so this point right here was 1, 2, 3, 1, 2, 3. So left 3, up 3. So right 3 and down 3 would put me right here. So that's a 180 rotation, where here would be my P prime. Let me put my other points in. Right, so visualizing this triangle now. Right, so I could rotate it 180, and then I could then translate it 1, 2, 3, 4, and then that's 4 right, and then 1, 2, 3, 4, 4 down. So this is just another option, right? One of many options that could work. So I did mine as a 180 rotation, and then translate 4 right and 4 down. Okay, but again, you could have many more options. You could reflect over different lines. You could have reflected over, x equals or y equals equations, and then slid it to its final position, etc. So many options for this problem. Okay, next up. So here in isosceles triangle, DOT, we're told that D is the vertex angle, and the ratio of base angle to vertex angle is 4:7, and we want the measure of angle O. So let's draw a picture. And I'm saying, okay, it's isosceles. So I have two congruent sides, and I would have two congruent base angles. And again, I can never really draw this to scale. I don't know exactly what each measure is going to play out to be just yet. Now I am saying that D is the vertex angle, so D must be in between those two congruent sides, the two legs. These are my two base angles. So O and T could be either of the base angles, right? Because they have to be the same anyways. So ratio of base angle here to vertex angle here is 4:7, and I want the measure of O. So I know that this can't be exactly 4 and this exactly 7 and this exactly 4 because my measures would not add up to 180. So to make them add up to 180, I need to add a multiplier, which is x. So I'm going to say, let's call this 4x to 7x for the time being, then build an equation to solve for each measure. So I'm saying base angle to vertex angle, so base to vertex is 4x to 7x, which means this has to be 4x also. So again, x is my multiplier that's going to allow my angles to grow big enough to add up to 180, but still be in the same ratio of 4:7. So here, if I add these up, I now have 15 x's that all have to sum to 180 degrees. Okay, divide away the 15 from both sides, and we get that x is 12. So that multiplier is just 12. So 4 times 12 would get me a 48-degree measure right here and here. And then 7 times 12 would get me, let's see, 7 times 12 would get me 84. Let me make sure that makes sense. Yes, so that's 96 plus 84, we're at 180. So that looks good. So which one do I want? I wanted one at the base angles. So right here, that would put me at 48. And if I just double check, right, base angle 48 to vertex angle 84, right, if I divided that 48 by 12, I would be back to 4. And if I divided that 84 by 12, I'd be back to 7. Right, so it really is the same ratio, right, because it reduces down to the same thing, 4:7. All right, last problem over here. I'm saying find the measure of CT. So what I have here is two base angles that are congruent, which means that I have two legs that are congruent. Right? These are my two sides that are congruent. Their measures must be equal. So then I can build an equation where I can say that x plus 2 is equal to the square root of 8x plus 9. Okay, if I want to get rid of the square root, I can raise each side to the second power. So I'm squaring both sides. Now on the left-hand side, this is a binomial. There's two terms that I'm raising to the second power. So I have to visualize this as this package of x plus 2 times itself. So here I have x plus 2 times x plus 2. And here if I multiply a square root by itself, it gives me the pair underneath. So it unlocks that square root and gives me just 8x plus 9. So then what I have to remember is that on the left, I have to FOIL this out because I have a binomial times a binomial. So my first x times x is x squared. My outer is 2x. My inner, also 2x. And my last is plus 4, all equal to 8x plus 9. Okay, here I have 2x plus 2x, so I can rewrite that as 4x. So x squared plus 4x plus 4 equals 8x plus 9. Okay, again, I have a quadratic equation. I want to pull everything to one side, and then I want to factor. So I'm going to take away the 8x from both sides, and I'll go ahead and take away the 9 as well. So x squared minus 4x minus 5 equals 0. Okay, so now I want to factor this down. So I'm just visualizing my product and sum, right? 1 times negative 5. Product is negative 5, and the sum is negative 4. So my two numbers that have to multiply to a negative 5 that add to a negative 4, it's going to have to be a negative 5 and a positive 1, right? Multiplies to negative 5, adds to negative 4. So here my factors are going to be x minus 5 times x plus 1, all equal to 0. So my solutions would then be 5 and negative 1, right? All I'm doing is setting each factor equal to 0 and solving for x. So now if I plug back in, let's say that I try the 5. So if I try the 5 here, 5 plus 2 would get me 7. Use a different color. Okay, and then if I plug in a 5 here, 8 times 5 is 40 plus 9. Square root of 49 is 7. So that works. So CT could be 7. Right? This value for x works. Okay, let's try the negative 1. So negative 1 plus 2 would be positive 1. And if I plug it in here, 8 times negative 1 is negative 8, plus 9 is 1, and square root of 1 is also 1. All right, so we see that we have two options that work here, right? X could have been 5. It produces a measure of 7. X could be negative 1. It produces a measure of 1. So two solutions, they both work here. All right, that's all I have for today. Have a good rest of your day.